Now we're looking for, this is part H, and this is 2, the average speed on this interval. So we have to go back, and again, the average, it's like saying the average value of the speed, so don't make more out of it than you see. So the average speed, so what's the speed, first of all? Well, remember the speed, you have to remember that is just the absolute value. That's equal to the speed. The average value of the velocity is the speed. And that's, again, one of the formulas that you need to know for your formula test. So again, we're going to do the same thing over here. This is the function that I'm finding the absolute, the average value, so I'm just going to put that in here. And it's over the same interval, so everything will be the same, so that's going to be 1 over. So the average value of the speed, which is the absolute value of v of t, is just going to, on 2, 6, it's just going to be 1 over 6 minus 2 times the integral from 2 to 6 of the average value. Of my velocity. That's all. And again, we're going to have 1/4, so we could just do this with our calculator, and that's going to be 0.25, and then I'm going to take the absolute value, and this is in y1 still. y1 2, 6, so that's what you got to do. That's all, and that's going to give you the average speed. And that's easy enough to do with our calculator, so let's get cracking on that. And we're just going to do 0.25, 0.25, math 9, and then we'll do math number, enter, then we'll put our bar, y bars, enter, comma x, and then from 2 to 6. So there you go, double check everything, make sure everything's put in, and poof. That should give me the average speed, or the average value of the speed on that interval. And we get 1.284. All right, so I hope that makes sense. All right, the last one. We want to find the average acceleration. Now this is where sometimes we have some issues. Now how do we find the acceleration? Well, we have to do the same thing for the acceleration. Now we don't have an acceleration function. Now we do have a velocity function. We were given the velocity function. And we do have the initial position. So this is a differential equation. This would be ds dt equals this. I could separate the variables, find the antiderivative of this, and then I would have a plus c, and then I could use the initial position, 0, 3, and find the c, and come up with the position function. Except, I don't think I could find the antiderivative of that. So that's a problem, okay? And that's why they do give you problems like this, where it's a little harder to take the antiderivative. So you have to show your calculator skills and how you could do this, or even your knowledge of what's going on. So this is something you better be aware of. So what we're going to do is, first of all, we're going to try to find the average acceleration on this interval 2 to 6. And we know just from our definition, that's going to be 1 over 6 minus 2 times the integral from 2 to 6 of a of t dt. Now remember, a of t dt is the same thing as, remember, the derivative of the velocity is the acceleration. I hope you can see that. All right, so the derivative of the velocity equals the acceleration. So therefore, the antiderivative of the acceleration is the velocity. And we could also, so watch out here, we could also write this as v prime of t. It's the same thing, isn't it? And what's the antiderivative of v prime? It's just v. Because if I take the derivative of v, I get a. So because v prime equals a of t. So I could write it like this, and I know the antiderivative of v prime is v, so I could just say this is going to be the same thing as v of 6 minus v of 2. Well, take a look at this. Remember, the velocity is the antiderivative of the acceleration because the derivative of the velocity is acceleration. So the velocity is the antiderivative of the acceleration. Because if I take its derivative, I do get the acceleration. So hope that makes sense. It's sometimes a little bit easier to see like this, because these are the same. Now I also had a 6 minus 2 over here outside, so I haven't evaluated this, so I'll just take this as 6 minus 2. And now I can find that value is what I'm looking for. So that's just going to be v of 6 minus v of 2, all divided by 4. So we can do that on our calculator easy enough because v is already, that's y1. So what I can do is I can just say and I put a parentheses around there and I go var, y bars, enter, enter. At 6 minus parentheses at 2. And all divided by 4. Negative 493. I'm sorry, negative 0.493. All right? And that's your average acceleration on that interval. So take a look at that. And this will give you a good understanding of what's going on with particle motion, I hope.